streaming right now, and let me go to the live stream page. Bup, 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 bup. Let me see. How's my stream health? I am live. Let me do a quick reload.
I'm looking at the live.
Yeah.
Right.
Do you see and hear audio?
I saw the video. I am live.
Cool. All right, looks like we're good. All right. We are live. All right, guys. We are live with bonsai.ai. Very excited here today with Mark Hammond, sorry, who is a founder and CEO of the company, who's literally just across the street from where I am, which is great. So we'll start with intros, and we'll then dive deep into what problems Bonsai is doing, their solutions, some history, genesis of the company, and where Mark sees the market and AI and DL over the next 5-10 years. So with that, Mark, I'll let you have the floor and for an intro.
Yeah, absolutely. So thanks so much for having me on. I really appreciate it. So for everyone who's joining, I'm Mark Hammond. As was said, I'm one of the founders and the CEO here at Bonsai. My background is actually originally very technical. I started at Microsoft very young, working on Windows itself and working on the first several versions of Internet Explorer and the first version of DirectX, which was immense fun, but my passion has always been artificial intelligence. So I pursued a course of studies at Caltech in computation and neural systems, and that was a tremendous amount of fun, but great in one regard and terrible in another. Great in that it was a lot of fun. Working at Microsoft in the late 90s was fantastic. Being in AI in the late 90s, a little bit less so, just because it's part of the AI winter. And so coming out of that experience, I more or less was trying to figure out how do we really apply all this technology. And the paths in front of me were go get a PhD, right? Go the academic route, or try to figure out how to make it work as a business, which was a very long game at that point in time. That's the road I chose to follow. So I switched tracks a little bit, went into product management, developer sales and marketing, a bunch of other things. Did do turns in academia, but really getting that rounded out exposure to building and operating companies, so that with the long-term intent of really coming back and saying, okay, I want to take AI and I want to do real-world applications of this. So that's kind of a background on myself. About 4 years ago, right before we started Bonsai, I had an insight. So I had just come off of doing work at Numenta as one of the engineers there, and another startup that was unrelated to AI at the time. And I was really kind of thinking through how do we make all this work? Because I've spent so much time trying to build the next great learning algorithm, but we really struggle to apply these things. So let's just do a thought experiment. And the thought experiment was very simple. It was, let's suppose someone does it. Someone cracks the nut. We have the best learning algorithm you can do. It's as good or better than humans. Doesn't matter. How then do we program it to do something useful? Because this is the application part, right? Mm-hmm. This is how do we do this? And I thought about it for a while, and it's one of those seems obvious in hindsight things, but didn't dawn on me for quite some time. No matter how good we make it at learning, you always have to teach it. And so I really just started to delve into that, and I said, well, we focus so much on machine learning, there's very little attention paid to machine teaching. And the way we are going to be able to make use of this technology effectively without everyone having to become a deep expert in machine learning and AI is to use that abstraction around what do we want to teach, how do we teach it. Let's focus on building tools and technology around that. And we can work on automating a lot of the other pieces. So that's what we've done at Bonsai. Bonsai is about taking machine learning and marrying it with machine teaching so that we can take engineers, subject matter experts, and data scientists, and machine learning and AI experts as well, and allow them to all bring their relevant pieces to the table so we can solve some real-world problems with that technology.
Wow. So it sounds like, this is a big idea, right? Which is to say you've got a bunch of AI guys, right, who's building this platform, and what you guys want to do is basically to open it up to allow non-AI practitioners to teach it, right? Is that accurate?
That's exactly right.
Right.
So it's we'll often use an analogy to a database because it's actually technically fairly apt, not just in the realm of describing the abstractions, but the structure of the technology itself. Nobody, when they're building technology applications that work with large amounts of data, sits down now and thinks about what tree structures should I be using, and when do I rebalance them, and how do I span disks? Like it's so that's a very low level detail. If you're
Right.
working on the database itself, yes, of course, then you think about that. But if you're building a inventory application or any of a number of business applications, that's a detail the database handles for you. What databases did is they came along and they said, hey, we need to give you an abstraction. We don't need to give you a toolkit that collects together all those algorithms. We need to give you a piece of technology and an abstraction. We're going to use relational algebra in this case, but whatever. And we're going to give you a special purpose language which lets you say, here's the structure of my data. Here's the kinds of questions I want to ask of it. Automate the rest. So that's the focus for what we do. It's just our abstraction is machine teaching. We give you a new special purpose programming language we've made called Inkling. And Inkling is really not about codifying what does your neural net topology look like. It's about codifying what are the concepts that you actually need to teach. How do you phase lessons to teach them effectively? It's very different in its structure. But in the same way that SQL let you automate the low-level mechanics of managing data, Inkling lets you automate managing the low-level mechanics of neural networks. So that's how the system works at a high level.
So that's interesting. So you guys are abstracting a lot of not just the details, but also it sounds like what do you train it with? What models do you guys use? You don't really care, right? Ultimately, you don't want the end users to care, whether it's RNN, CNN, unsupervised reinforcement. It doesn't matter. Is that accurate?
That is accurate. That is the objective and what we're aiming to do. And the language is the piece that makes that possible through that abstraction. And to be clear here, the database analogy here is useful as well. Even when you have a database, there is a role to be played by someone who has that low-level expertise. We still have database administrators. People still dive into the details of the slow log and figure out which volumes indices should be placed on, and what they know that because they work at that level of detail. But that's a specialty, right? That's not what your typical programmer who's using the database does. They're focused more on the business logic and all the arcana and difficulties that are associated with that. So data scientists and machine learning practitioners still have a very big role to play, even when you're using a technology like Bonsai's platform. It's just that it's now intermeshed so that everybody can play their role. The subject matter experts know what to teach.
Yeah.
Right.
If you ask me...
Sorry, let me interject and ask a quick question.
Yeah.
So I think when we report a Bonsai is getting funding, one of the questions from the AIDL members, and as you know, there are a lot of experts type of guys there, and what they're asking is, in fact, it is just another way for you to explain to us what you're doing is different, right? What is the relationship between Bonsai.ai and all these deep learning toolkits, which is open source and available in the planet? And so you must be doing an extra layers on top of that. So how will you characterize that layers? And then will you explain to us?
Yeah, absolutely. So typically, if we look at what's broadly available now, there's really three general categories. There's the toolkits, as we already are very familiar, TensorFlow, Keras, even on top of them, right, as an abstraction layer there. So we're all familiar with those. There's APIs, which kind of instead of taking the tack of let's expose the low-level mechanics of how the machine learning works, let's pick a specific slice of functionality and abstract that so that we can give you something contextually specific and hide most of the AI. And then there's all your statistical analysis packages. So these are kind of the three main areas that various tools and platforms fall into. Ours really is somewhat unique in that it's very different from any of those three. It's most instructive to look at the toolkits because oftentimes people will compare us to something like Keras because they also are an abstraction layer on top of a toolkit like TensorFlow. And It's different levels of abstraction. Keras is around abstracting the mechanics for the algorithms and the learning systems themselves. We are around abstracting, focused around machine teaching. So at the end of the day, our system, when it compiles, it's a full-blown normal programming language. But when it compiles into TensorFlow-style code. Now, it's all running in the context of our platform, and there's a host of reasons why that's necessary. But we are generating the low-level systems that are going to do the learning, but we are following the curricula that have been specified in the Inkling code. So you're not saying, I want a convolutional neural network of this type, or I want a recurrent network of this type, or whatever the things you might do using an abstraction like Keras are. What you do in our system is very different. You say, I want to teach this concept for this robotic system that I am building.
I see.
Right? And when I want to teach it grasping, it's instructive for me to teach it in a phased way. So oftentimes I will use another intuitive analogy here. So I have a son, he's almost 5, and he's learning to play baseball. So it is not important for me to understand the inner workings of his brain to teach him how to play baseball, right? Like, I have a neuroscience degree, so I know some of that, but that's it's not important. That's not what matters. What matters is that I understand the core concepts of the game that I need to impart to him. He needs to understand the rules, he needs to understand the skills, and if I pick any of those skills, say hitting the ball, I don't teach him by taking him out to the backyard and throwing fastballs at him, because he's 4. It's neat. Why would I do that, right? Like, it's just cool. So what do you do instead? Well, I take him out to the backyard and I put a wiffle ball on a tee, and he practices. And when he gets good at that, I set the tee to pop the ball in the air. And when he gets good at that, I pitch it underhand to him at close range, and so on. Right? There's a progression of these lessons. Now, since the people who are listening to this and watching this are practitioners themselves, we understand more of the details for how that works. So I'm going to speak a little bit more in mathy terms. You're constraining the state space that needs to be explored. That's it. That's all you're doing, right? So if you just throw the baseball at him as a fastball, it's the exact equivalent of me taking a big, giant data set of the end result that I know we want and just sticking it in front of my machine learning topology and algorithms that I've set up and saying, go. That will work. We have great machine learning technology. It can chew through that massive data, and it will learn, and it will work. And I'm sure if I pitched a fastball at my son a million times, he would figure it out eventually too. But it's just totally inefficient. It doesn't make sense, right? We know, because we have subject matter expertise around whatever it is we're trying to teach. We know how to guide that. We know what works. We know what doesn't work. We know what the fundamental concepts you need to grasp are. So we just kind of give you a way to set those guideposts and map that out. So it's a really fundamentally a different way of thinking about how you solve a problem. It's not very much akin to a toolkit or a Keras abstraction on top of a toolkit. It is its own thing. Machine teaching is really about how do I, regardless of the machine learning algorithms I'm going to use, how do I specify how I can efficiently and effectively teach intelligent behavior, the intelligent perception, whatever it is that I'm after, in such a way that I can do that effectively for the system. So we can use an example here. So we're all practitioners. So let's say we're doing a deep reinforcement learning task. I want the system to learn how to play a video game. Let's say Lunar Lander. If I was going to do that, I might go say, hey, I can use a DDPG, deep reinforcement architecture. That's a fairly modern, sophisticated architecture to use. And maybe I go implement that myself, or maybe I go use something like a Keras to make it easier to lay something like that out. And okay, you can go through all those motions, and then you set it up so it plays the game, and it plays. And if you set that up properly, it'll learn to play the game in something like 2,000, right? So you can run 2,000 episodes, it'll figure it out. If you teach it, so you teach it these core concepts that are part of the game, maintaining stability of the craft, getting the craft over the landing site, landing gracefully so that you don't go so fast you will crash. You can learn in 50 games. So we have results where it's not 2,000, it's 50. And the reason that works is it's from a pure math perspective, you've just constrained state space that needs to be explored. It's not magic. But because we know something about what we're trying to accomplish, we can guide the system more efficiently and effectively towards the answer that you're after. That's all that's really happening.
Got it. So that's fascinating, right? You're basically saying that, like, look, whatever the application is, there's a set of human constraints or whatever your objective are. And instead of just throwing, here's all the training data, we can put the constraints, right? So your search space is a little bit, your state space is a little bit, a lot smaller. So if I go to the other side of the coin, in cases where uh, uh, we may not know, I'm trying to think out loud. Are there cases where the humans don't know what patterns or what exactly the objective is, and where you're just basically saying, find the pattern, right? So in that case, does that not apply here?
No, it totally applies. So that's the beauty of using a system like this. So actually, since we're all, I love that I'm talking to an AI crew. It's great. So in the 80s, we had our expert systems, right? And our expert systems were all domain expertise, all subject matter expertise, all the time. It was all that, and we all know the failings that came and successes. There were some, but it was not deemed to be a success, right? And that pendulum has now swung entirely the other direction. It's now no subject matter expertise. Just give me the data. I don't want to tell you anything about it. It should be able to learn from just the data. And it works, and it's amazing. That's the power of deep learning technology, is that it can do that. But if you leverage both together, then if you can tell it because you do have some subject matter expertise, it can go a lot faster. And if you can't tell it because you don't know, that's also okay. That's not a problem. Right? The system will still be able to learn. It's just going to be a little less efficient than it could have been. So it doesn't preclude that at all. In fact, it just makes it more flexible in how you decompose your problems.
Interesting.
Let me try to chime in here. It seems like what you are suggesting Bonsai is doing is a kind of human-guided learning.
Yes.
And just on top of my head, I think you make a very good example, which is this type of technique will work, will make a lot of sense in the case of situations like reinforcement learning, like playing games, robotic control, and all the use cases of control and RL in general. Is that a right characterization? Which is, I believe that what you're exposing is allowing users to easily change this guided learning for Bonsai. Would that be correct? Yeah,
that's completely correct. So our initial go-to-market for the company has been focused on control and optimization problems, and it's basically applied deep reinforcement learning. Right? Those are the majority of the problems that we are working with real enterprise customers right now. There is no reason you couldn't, in principle, use the exact same abstractions and language constructs and tools to tackle problems around perception or data mining, or we can go into all the other use cases for AI. But that's not the low-hanging fruit for this kind of an approach, right? So for us as a startup company, we chose to focus initially really on control and optimization, applied deep reinforcement learning. We will expand more and more over time into those other domains, and certainly we provide mechanisms for you to incorporate models that you created in those other domains. If we do robotics, you mentioned robotics, that we do a lot of that kind of work. In robotics, vision matters a fair bit as well. And people already have a lot of existing vision models. So it doesn't make sense to go reinvent the wheel. So plotting those vision models in, that's great. When you want to learn the control loop for the actual torques on the motors in the robotic armature, then that's another story, right? So that it kind of just depends on the application area, but your intuition that this is really well suited for reinforcement learning, 100% agree with.
Mark, let me just look at all the members and tell them something important. Hey, Bonsai.ai really has nothing to do with carrots. It's way cooler than carrots.
Yes.
Just extract all this information from Mark. Okay? Now, this is questions you have. Bonsai.ai is totally not a layer work upon TensorFlow, Theano, and CMTK. is totally cool. So check it out. But hey, that was. But to be honest, it really answered one of the biggest questions in my mind because when I first look at the company, I thought that it's more like H2O.ai, which is like a layer on top.
Yes.
But the fact that you guys are focusing on reinforcement learning is really, at least I believe it is more like the future of both deep learning and perhaps AI. Not that the technique is new, but the fact that no one really spent commercial space money on it makes it a very interesting challenge.
Yes, and from a business perspective, it's another good reason why we, aside from the alignment with machine teaching as an approach, that market's underserved. So there are a whole host of companies that really dearly want to use and apply machine learning and AI technologies, but they're not sitting on a big giant pile of data, right? They don't have the Hadoop cluster and the data lakes and all that kind of stuff. What they do have is massive simulations that they can leverage, and so the only way to really effectively take advantage of that is to either run them and record lots of data, or utilize reinforcement learning style techniques. And so it's an underserved market, lots of real world applications, things people don't even think about. Robotics is the easy one, right? It's very straightforward. Oh yes, robotics, we're going to do that. But it goes to many, many areas. So urban planning, even your appliances. So your dishwasher, it has a smart setting on your dishwasher, and you don't think about what that actually does. But it's just another form of a robot, right? It's not a robot in the classic sense, but it's still a robot. It's going through a control loop. It's the same kind of thing.
I guess another example that Wakil and I can relate maybe is banner ad showing and what using reinforcement learning type of technique to show when do you want to show certain ad, and I think that is a very good application too. So let me ask you this: it sounds like Bonsai to me has certain research element in the company as well. How would you compare yourself with all these powerhouse startup like OpenAI, DeepMind, or Maneuver? Would you think that you want to develop through that route, which is you will just get a lot of researchers hiring 10 Andre Kapave and then grow it that way, or are you thinking of more like a business model which you're selling service like a SaaS type of model? So what do you think you are going to?
I mean, so we are very much an applied artificial intelligence company. So there is a research element to what we do, and we will have our own papers coming out in short order, so people will be able to see some results as well. And we do push the state of the art in certain areas. However, it is more important from our perspective as we look to enable people to use the technology to really put the pieces, the tools, the platform, all of those abstractions in place around it so that you can leverage it. So we think the work that the crew at OpenAI and DeepMind are doing is fantastic, and we incorporate and make use of it. The fact that it's open research and is shared with the community is fantastic. We would very gladly take the latest and greatest techniques, incorporate them into the platform, allow our users to take advantage of them. So in that sense, we're really applying the technology more than we are doing pure research on it. And we are very much a developer. Our company sits at the intersection of developer productivity and artificial intelligence. But we're bringing the two together. My background, as I said, early days in Microsoft. Well, I shouldn't say early days, but mid-90s, right? So good times to be at Microsoft. My co-founder was also, we met originally at Microsoft.
By the way, it's still good to be in Microsoft, just to stress that. But you go on.
I am still a fan. I worked there a long time. They're one of the investors in the company, right? I totally get it.
We're huge fan, Sponsor us, we are bigger fan. But go on, sorry.
No worries. So my co-founder worked on Visual Studio itself. Funnily enough, when if you were developing applications with Visual Studio, and they would crash, and a pop-up box would come up and say, "Hey, your application crashed. Would you like to send a report back to Microsoft?"
No grudge for me having
Yeah.
that.
Well, so when those happen and you click them, there was actually someone on the other end. That was my co-founder, right? Like he actually got all those reports. So we are very much aligned with developers, making developers successful, giving debug experiences, giving proper tooling, getting all that stuff in place. So at the same time that we have expert AI members of our staff, we also have expert compiler authors on our staff, right? So it's an interesting mix. It's when you go to try to apply the technology, you need both. It's not enough to just be a research-oriented operation. We also have to marry that with, and here's how you build proper tooling to enable people to use it. So for us, it really boils down to being applied. We're an applied AI company.
Right.
And Mark, quick question: how do you? Oh, sorry.
So I just want to conclude that part. It seems like you guys are not going through the route of like OpenAI or DeepMind or Maneuver. Basically, they are research company and got bored by basically an arc behind in the process. But you guys have, in a way, it is more like a SaaS type of business model, and then sell it to enterprise level clients. But I just want to wrap up this part. Why can't you should go on?
Yeah, I was actually, it's related to your question, right? Which is, how do you sell? Do you sell to? So it sounds like you guys sell to developers. Who do you sell to? What does that look like? So if I say, hey, this sounds really cool. I'm a developer, or I'm the head of the machine learning development team. This sounds really awesome. I want to adopt it. Like, what happens then for them to interface with your system? Do they have to run it on your cloud, or like, how does that work?
The best way to think about it is in relation to a database. There is a actual server runtime system that you are going to run. Whether that runs in our cloud, your private cloud, on the device, that's kind of dependent on the application that you want to run. We certainly do have our own cloud, and if you have an account on our beta system, that's running on our own servers, right, in our own cloud. But interestingly enough, for most of these kinds of reinforcement learning applications, because they are so heavily dependent on simulations, most customers want to run on-prem. So most customers are actually purchasing licenses for the software itself, running them on their big iron, and running it locally. That's. I know it's 2017 and that seems quaint, but that is 90. The statistic from Intel was 96% of simulation workloads are still run on-prem.
Yeah.
They're not running them in the cloud.
Yeah, I can see that.
So we go where the customers are. It is a commercial offering, so it is much more akin to licensing a database server to use. We have an early access program that we spun up in the beginning of May. We're engaged with a number of very large industrial and commercial enterprise companies who are using it to tackle real-world problems today. And generally speaking, there's a couple ways for people who are interested to get involved. The first is if it's a potential fit for your application area with your company. Getting in touch with us around the early access program, we'd love to get.
Yeah, you know what we ought to do if you have that program that people can sign up online. Once this is over, we'll repost it into the group, and also have it make sure that it's in the description of the video, so that people can sign up.
Yeah, absolutely. We can definitely make that happen. And then we have lots and lots of documentation online, lots of examples to work through. There's stuff posted on GitHub. Everything from solving various video games for fun to real-world applications for optimizing energy consumption in buildings, things of that nature. So there's a whole host of those that people can go in and take a look at, and I'm happy to get that kind of information out to the group.
You in the startup world and also doing AI and machine learning. One of the feedbacks I got from a lot of industry people is they just find it very difficult to hire the right people.
Yes.
So we learn a lot about these situations, but can you share a little bit about your experience as well as how do you usually approach talents yourself?
Yeah.
So please, yeah.
Absolutely. So when we first, it's a good question. When we first started the company, our hypothesis was that the challenge was that the talent was too expensive, right? That if you were a Home Depot, that going after the top tier AI talent was going to be outside your budget range, right? This was our belief. And what we discovered when we started really going out and talking to everyone was actually that's not the problem. These companies would gladly pay the premiums to hire these people. There just aren't enough, right? There just aren't enough trained people who have the low-level skills of using technology. So there's a big shortage there. That's a very real problem. And when you, as someone who is a skilled practitioner using the tools, are facing an offer from Amazon or Google or Microsoft or Facebook or Twitter, pick your choice of top tier tech companies, or going and working in they're still a very big, very large and powerful enterprise company, but not the same kind of pure tech focus. It's hard. It's just really hard for them to compete. So we see this all the time. That being said, the analogy I like to draw here, because I think it really kind of frames everything correctly, is that the state of AI today, and it's easy for us as people who are steeped in it and working with it every day, it's easy to forget that for almost all of the rest of the world, it's like it's 1995. Everyone realized they need a website, and half of the people don't know what that is, right? Like this is reality. When you actually go out and talk to companies, so that it is not uncommon for us to go and engage with a company and to have them come to the table and say, "Hey, our CXO level mandate is figure out how we get on top of this AI thing and apply it to our business. Tell us about that," right? Like, and they really don't know. They're looking for guidance, and you run from that all the way to the other end of the spectrum, where you'll go down and you'll sit down with an automotive company, and they will bring 3 PhDs to the table, and they want to dive immediately into, well, what kind of recurrent neural network topologies do you support in your compiler, and everything in between. So it's just this huge spectrum at the moment where the market really understands that this is important, but they don't understand what exactly they can do with it and how to do it yet. And so that breeds a lot of opportunity. It's actually a really good thing, just in the same way that it was a huge opportunity with the web. It's a huge opportunity now. But it means that the talent isn't there. And it's not there because there aren't enough people who are trained how to do it. So there will be demand on all ends of the spectrum. Our approach to solving that problem is to empower the people who do know how to do it to do more, and empower the people who have subject matter expertise that are already in the organizations, and empower the developers who are already in these organizations to use the technology. But there will still always be a need for people who are tremendously deeply skilled in the same way you always need database administrators and whatnot as well, and people who can really dive into the mechanics of how all that works. So that will continue to be the case. I don't see that going away anytime soon. So if people say we're going to solve this through education, and I say, yes, that will help, because we will go from having tens of thousands of practitioners who know how to do this to having hundreds of thousands of practitioners who know how to do this. But we need millions, right? And so it's not enough. It's going to help a lot, but it's not enough. You need to come at this from all angles to really solve the problem.
No, that's really interesting.
A question here is, sorry, Wei-Kit again.
But
the interesting part about your background is that, so you're a little bit like us, okay? You're younger, actually. You're a little bit like us, who went through both the web hype, and then now we're seeing the AI kind of craze. Yes. I'm not going to say it's a hype or not, okay? Sure. Because we are administrators, we are supposed to be objective. So, I mean, how do you see the similarity and difference between these two, great trend in outline, the web trend and the AI trend? Do you believe that the developments of that trend is similar, or do you see something different between the people involved in the growth of the web and the people involved in the growth of AI? Does it make sense for that question?
It makes total sense, and I think that what you're latching onto here is entirely correct. It is, from my perspective, and I'm not an administrator, so I don't have to play the objective role, right? From my perspective, AI is the next big technological wave. We went through the desktop productivity. We went through the web. We've gone through mobile. We've gone through social. AI is the next wave. I wholeheartedly believe that. I think it's safe to say most of the rest of the industry believes this as well. It's why there's so much massive investment going on in it. And there are a lot of lessons that we can learn by watching all of those. It's not just the one from the web. By watching web, mobile, social, and all of them together, you can see a lot of the same trends repeating themselves over and over again. So one of the things that's fun that happens now is you will have all these fun reports where it's, hey, here's the top X AI companies in the space, right? And they come out and they always carve it up in some way. So here's AI as it's applied to healthcare, and here's AI as it's applied to fintech, and here's AI as it's applied to automotive, and so on and so forth, right? And that's all very, very real. But the thing that I would encourage people to recognize as where is this going, and it's going to go there. There's nothing any of us will do to stop it. It's going to go there. Is no one says this is the web-based healthcare company or this is the web-based fintech company. Having a web aspect to what you're doing is par for the course now. It's expected. Everyone expects that to happen. We just went through this in mobile. Right? We're this, but on your iPhone is no longer a thing, right? That's of course. If you not have a mobile app, if you don't have a mobile app, what are get with the times, right? AI is going to be the same thing, and that's great actually for the field, because what it means is that people will start more or less taking it as an expected thing. It's going to be taken for granted. Yeah, I expect my system to behave intelligently. What do you mean you're not doing AI? Of course you should. Why is this so? This is a dumb interface. It doesn't have a clue about what's going on. Why is this? So we can follow that trend. It also means that AI for healthcare in 5 years' time will be healthcare. It won't be AI for healthcare. It's just healthcare, right? It's healthcare. Now AI is an expected feature. Same thing for any slice of the market you want to take. Other than the core technology groups themselves, that it's going to just be melded into everything else. And that means there will be industries that get disrupted. It means that a lot of AI companies will be acquired by incumbents. But this is a natural evolution in any technological way. That's actually not an AI specific thing. That's any. It's just that we can look back at what's happened before and see a lot of constructive things on what's happened. With all of these other fields, if we look back at the web, there was a period of time where people spun up dev shops and they were just like, oh, we are a Linux dev shop, or we're a web dev shop. And people threw money at it, like without rationale for why, right? Oh, and companies went and acqui-hired companies just to get people who knew how to do something beyond CGI scripts, and like all this stuff. It's all happening again. The same thing will happen again. So that's kind of what I expected.
And Mark, along that theme, we're sort of the early innings of this long arc, right? What seems to be a long arc. How much, and you talked about lack of talent as sort of one driver of why platforms like yourselves are compelling. Well, you also touched a little bit earlier on in terms of lack of data, which in some case, even if you have maybe even bigger problem, you could have all the talent in the world, but you just don't have enough training data. How much of, when you talk to your potential customers and your customers, how much of the data versus talent sort of drive their decision in terms of looking at a platform like yours? You think it's more talent right now versus data in terms of, we need something like this?
The real answer to that is it depends who you're talking to. So if I go and I talk to a very large Fortune 500 company, they don't have a data problem. They have a lot of data, right? They are lacking the talent to work with the data and make sense of it all. If you go and you talk to a startup, they are at a data disadvantage. They are not sitting on a big giant stockpile of data to work with for their training. So for them, it's actually more natural that they have the talent. They're a startup. They've got a bunch of bright young men and women who are going after tackling this problem using this great new technology. That's not their issue. Their issue is the data. And so it just kind of really depends on where you're at. And that's actually why you see a lot of the acqui-hire kind of stuff going on, right? It is not an abnormal thing for me to talk to people who are now at one of these Fortune 500 companies were at a startup. The startup was acquired because they wanted to get the talent. And I will say, well, why did you do it? Why did you choose to join big company X? And the most common answer is because that's where all the data was. Right? They have the data, and so it was a tough battle for us to wage to fight them on that front. We went where the data was. So that is a real thing. I think from the perspective of, do you need tons and tons and tons of data? The answer is that depends on how sophisticated your teaching is. So, of course, I'm totally biased, but from an intuitive perspective, again, I'll give you another intuition here. Humanity learned calculus. It took us many millennia, right, to figure out calculus, and now we can get most high school and college students through it with pretty good consistency. And we can do that because we reduced it to a understood curricula. It consists of a set of concepts that we need them to master, the order in which they should do it, how they relate to each other, the lessons we use, how we pose artificial problems to test that they've understood things and have them go through those tests. We don't have to ask them to go from first principles, right? Like it's not, hey, here are the piano axioms. Yeah. Go figure out calculus. Right now, if I gave you enough data, could you do that? Yes, but it seems completely inefficient. And that's a kind of a funny, intuitive example. But even if you're not using a tool like ours, and this would be my message for everyone listening, who obviously are practitioners being part of this group. Even if you're not using a tool like ours, really start to try to think about how you tackle the teaching side of the problem, not just the mechanics of the machine learning side of the problem. Because oftentimes the problem is not the topology you set up. It's not the hyperparameters you chose. It's not any of those things. The problem is you didn't actually structure the way that you introduced all the data or all of the simulation environments or whatever in a way that was conducive to learning. Right? So start to think about it from that perspective, and we will run into companies who are already doing reinforcement learning. So, right, and people are using this technology. So we'll run into companies, they're building autonomous systems, or they're building various vehicles, or whatever it happens to be. They're using reinforcement learning techniques already. And the more sophisticated they are, the more they're already doing this. And so then the proposition to them is different, because to them it's not, oh, here's this thing which abstracts away the low-level neural network stuff. To them it's, oh, I now have a formal way to codify what I was doing by hand when I did my training and curated my data set and did all these, oh, that sounds great. So it's interesting. People don't think about teaching. I would encourage people to think about teaching. It's part and parcel with learning. You need both. They go hand in hand.
I can echo that point by telling you a lot of people couldn't differentiate a problem categorize a problem to supervised or unsupervised learning.
Oh, sure.
That astounds me from time to time. And those are people who are quite sophisticated technically.
Sure.
But when you ask them, well, this is clearly an unsupervised learning problem. Why do you apply backpropagation as the algorithm? Mm-hmm. Sometimes just that simple question just done them. And on the point about big companies, they will try to repeat technical stuff in general, and I can't agree more. But that also kind of say there are a lot of opportunities for small vendors, because a lot of times if you don't have expertise, even if you're a big company, my experience tell me that a lot of these big clients, they just do things a little bit incorrectly, and then that crash the system. And it really takes expertise like yours and all the small companies that we feature from time to time to really solve this kind of problem. But sorry, I interrupt. But that's a very interesting.
Yeah, I agree.
So changing gears a tiny bit, we've got some user questions. I think so. Drew Volpe just asked. I think some of this might have been answered a little bit earlier, but let's give it a shot again. So Drew asked, we hear a lot about machine learning being used by consumer applications like Google, Facebook, and the like. Can you talk a little bit about some of the differences of applying machine learning in industrial areas?
Yeah, absolutely. So, actually, a funny one is that when you look at industrial contexts outside of the consumer ones, there's a lot more reinforcement learning. Let's start there. From a pure technology perspective, there's a lot more reinforcement learning that makes sense to do. There's also a much greater dependency on being able to explain what's going on. So if it's Netflix and we have a consumer app and it's going to predict what movie I'm going to like seeing, and they get it right or they get it wrong, it increases or decreases my enjoyment of the movie and the experience, and that's important and very valuable. But it doesn't. At the end of the day, whether or not they can say it's because this genre or this or that, whatever it happens to be, is not critical. Whereas if you're going into an industrial and commercial enterprise setting and you're working on their supply chain logistics, you're trying to optimize that. And they have built a very sophisticated discrete event simulation model tracking movement of goods between warehouses and retail doors and production factories over land routes and air routes and sea routes. And they have to account for weather and all these other kinds of things. And it comes back and it says, well, have the truck leave the warehouse now and depart for this location. And that's all it says. The analyst who's sitting there, whose job is to decide whether that's the right thing to do or not, they're not confident in that. They're not okay. That's not enough. Even if the system is right, and even if we as practitioners in machine learning can say, it's actually going to get a better result if you just trust it and let it do its thing, they really, really want to be able to explain and understand why. So they need to have that ability to go back and say, well, we're saying you should have it leave now, even though it's only 2/3 full, because we're tracking a storm front in the Midwest, and that's going to cause delays on this overland route, and so on, whatever this chain of things happens to be. Because that gives them confidence in what's going on, it gives them the ability to debug what's going on, et cetera, et cetera. So explainability, understandability, confidence is a much higher priority when you get into these commercial and industrial contexts. The other one is safety. So if you are working around big industrial robots, they can hurt people. They can kill people. Nobody wants that. That's bad. That's a very bad thing. And so the way they solve a lot of these problems now is you put cages around the equipment, right? Just don't come in when this equipment is operating. That is a bad thing. Don't do that. And why is that? It's because the equipment is fully automated. It's doing a set thing over and over and over again, and it's way stronger than humans, and it could hurt you. They have a strong desire to enable humans to work more closely with these systems and be confident in their safety. So this is another concern that becomes very apparent. So those are two. And then the other one that I would really highlight, which we've already touched on before, but it is a big difference, is the difference in dependency on just large data sets versus interactive real-world environments that are either the real equipment or running through simulations. That's a big difference as well. For a lot of the consumer applications, that is not as pronounced. Whereas if you are building a smart wash cycle for your dishwasher, and you have a very elaborate simulation model for that, at the end of the day, you're still going to have a factory floor somewhere with hundreds of dishwashers and people loading them with dirty dishes so you can test it, right? It's very different. So when you get into these contexts, that's a huge difference. And then actually, I will highlight one last thing, which is the scale and scope of the problems. So let's say you have a piece of machining equipment and you're wanting to add intelligence to this piece of machining equipment. And this machining equipment is manufacturing aircraft parts. It could take 1-2 weeks to manufacture a part. And that part could cost $250,000. And if there is a mistake that is made in day 2 of that process, and you don't catch it until day 6 of that process, you can just do the math in your head how much money was just wasted, right? So for these companies, there is a massive incentive to really kind of drill down and figure out how can we leverage this technology to deal with these problems in a more effective way. For that kind of problem I was just mentioning, where you're machining this part over a course of weeks, they literally pay people to sit there and watch the machine run. That is their job, is just to watch it run. And they have to be highly skilled. This is not a low-skill job. It's a high-skill job because you have to be really smart about the operations of this equipment and what you're looking for and what could go wrong. But your job is to watch and just detect when something happened that is the problem. So there's a lot of opportunity, a tremendous amount of opportunity in these areas outside of the pure consumer context.
So, Mark, I think I want to ask one more question, which is very specific to you.
Sure.
Because your background is very interesting. Your undergrad actually works for Crystal Corp, if I understand correctly.
Correct.
And your background is really computational neuroscience and cognitive neuroscience. And so we all know that neuroscience type of subjects have a lot of relationship with machine learning, and yet at the same time they are very different. So,
yes.
So to our members, how would you describe this difference between cognitive neuroscience or computational neuroscience now versus the machine learning that we are using right now? What will you see the similarity and difference between the two subjects?
So there actually is more overlap now than there has been in the past. I'll start there. So if we looked at Bayesian systems for learning and things of that nature, there's a good, solid computer science mathematical foundation for all of the learning that happens in those kinds of algorithms. When you look at the machine learning that's happening with deep learning networks and things of that, going back to the revival of the artificial neural network, it has more direct mapping into neuroscience. As I'm sure you identified in my background, I have a lot of ties back to the neuroscience community, where they have gone to. I spoke with one professor just casually, and he had just come back from a conference, and they were discussing what the neural correlates of something like AlexNet were. And there was a healthy, fevered debate about, well, does this really map to the neuroscience, or does it not map to the neuroscience? So it's close enough that yes, you can make those overlapping comparisons, but it's still not trying to replicate the brain, right? There are companies whose focus is, I believe the correct level of abstraction is that we have to simulate the ion channels in neurons, right? And if you don't deal with spines correctly on your dendritic tree, you're not going to get the behavior you want. And there are people who say, no, that's too low level. Really, if you just model a neuron as a unit, and we have a spiking model, that's the level it should be at. And then there are people who will say, no, an artificial neural network is close enough. It is, yes, it's not actually faithfully modeling a neuron in any reasonable way, but the fact that it has real valued weights instead of a spiking model merely is compensating for the fact that we don't have to do rate encoding on the spike trains, right? So you get this broad spectrum, and the truthful answer is no one knows where the correct point to draw that line is. And so if anyone comes and tells you they know, I would love to talk to them, because I want them to tell me, because no one knows, right? I don't know where the right place to draw the line is. From a technology perspective, I think there's a lot of areas where this can go. GPU-accelerated neural networks are very powerful. They're also very power hungry, right? If you can replicate the same thing using a spiking model, using a technology like Qualcomm's neuromorphic computing systems or IBM's True North systems, and you can do the same thing in 3 orders of magnitude less power. Now, is there a rich tooling infrastructure for training those things efficiently? No, definitely, it doesn't exist at the moment. But to me, that's really exciting, because what it tells me is we are doing all this work now, and in the years to come, we are going to see massive advancements in the underlying computing infrastructure. We're going to see massive advancements in understandings around what the appropriate learning algorithms to use are. All of that can be inspired by the neuroscience and the biology, and I think that's a healthy thing. But I also think that we're not trying to replicate the brain, right? That's a separate exercise. It's a fascinating one. I love it. Personally, I have a strong tie to it. But they don't have to be mapped one-to-one, in my mind. In my mind, the brain is not the only example of a computational intelligence system that can be. But we can learn, but it is the only example of one we have that works the way that we know it works. And so using it as a reference point to learn from is very powerful. And I see a lot of that happening. And I look at the advancements happening in the core computing infrastructure, and I just see tremendous opportunity and growth and advancements and capability ahead. I think we will look back 10 years from now, and we will say, wow, all this GPU stuff, which is, by modern standards, amazingly powerful stuff. And we will look back and we will say, wow, how could we have been so naive about how we were doing that? And so that just seems like a natural evolution to me. It also seems natural to me that the number of people who need to be focused at that level should be shrinking. Where we will only scale as an industry and a discipline if we enable people to work at higher and higher and higher levels of abstraction closer to the real problems that they're trying to solve. So I think that's just a healthy maturation of the industry.
One thing I want to say, well, at least to the members as well, because we are more like the AI group, machine learning group. So, so part of what Mark is saying is the current neural network that you are using in TensorFlow and Piano, they're static. There's no time information there. But if you use spiking neural network, the promise is the timing of the spike is supposed to transmit information among individual neurons. And you also mentioned dendritic computations, which is really kind of model the physical topology of real biological neurons. And it was we got as one of the most important physical theories for computational neuroscience. And so one remark I will put it there is, I think it makes sense that people start to put focus on neuromorphics because it's more like one level more sophisticated than the static neural network.
Yes.
Yeah. And so if you ask me to guess, maybe that if we really master that, maybe the next step will be dendritic computations, which do fundamental models type of thing. Yeah.
I would simply say I think deep learning technology is great. I also do not think it is the end. I think it is a step along the path. We can have all sorts of debates about what the next step is, and I'm glad there are a lot of very bright people and creative startups working on exploring all of those things. And I look forward to seeing what comes out of it. It's just a step on the path. This is not the end by any stretch.
No, this is great. We're coming down to the last minute, literally. And Mark, this is awesome. Super enlightening. Really exciting stuff that you guys are working on.
Thank you.
Very insightful stuff. I think you guys are kind of looking at it from a very particular angle, which I think is timely, certainly. So thanks for taking time out and spend time with us. Hope you come back again. We'll offline get the links and repost it back into our group. And exciting stuff.
Yeah, thank you so much for having me. It was a pleasure.
Our pleasure too.
Thanks, guys. Bye.